Section 10.4, we're going to be looking at the tangent ratio. Now, in 10.5, we'll look at sine and cosine ratio. There's no difference between them, really. There's no reason that we're separating the tangent. It's just how our book does it. So we're first just going to look at one trig ratio. So trig ratio, what is a trig ratio? It's a ratio, which just means a fraction comparing two numbers, of two side lengths of a right triangle. Now, trig ratios only work for right triangles. And we're going to compare two side lengths. So there are three trig ratios we're going to look at: sine, cosine, and tangent. And they are all different because they all are different depending on what side lengths you compare. Well, the tangent is comparing the opposite leg over the adjacent leg. So fill in those blanks: opposite over adjacent. So again, there are three different trig ratios, and here's a way that you can remember all of the ratios. SOHCAHTOA. You've probably heard this before. S stands for sine, C stands for cosine, T stands for tangent, and we're only focusing on the tangent trig ratio today. Well, the tangent is the opposite side over the adjacent side. Now you're like, what? How do I know where opposite and adjacent sides are? It depends on what angle you're talking about. So if I say find the tangent of this angle right here, then you would do the opposite side over the adjacent side. Now, opposite is across from, so this would be opposite of this specific angle, and then this would be the adjacent side because it's right next to it. Okay. The other side that we don't use for a trig ratio is the hypotenuse, and you guys are good at identifying the hypotenuse because you know that it's across from the 90-degree angle. So this is the easiest one to label right away because you guys know how to find the hypotenuse. The opposite then is across from the angle, so I would label that one next, and the adjacent is the remaining side, which is right next to the angle. Now, why isn't this technically is right next to the angle too, but we know that it's the hypotenuse, which means that this one has to be the adjacent side. So today we're just focusing on, they'll tell us what angle to find the tangent of, and we'll do the opposite side over the adjacent side. So that just talks through the same thing that we just talked through. So find the tangent of angle S and the tangent of angle R. We're going to first do it in fractions and then as decimals rounded to 4 decimal places. So the tangent of S. So we're just focusing in on angle S. So I'm going to label the three sides according to S. So first, I always start with hypotenuse because that's across from the 90-degree angle. Then the opposite is the next one that's easiest to identify. Opposite is across from the angle, and then that means 4 has to be the adjacent side. So if we're trying to find the tangent of angle S, so you always write the tangent of the angle, so tangent of angle S is opposite side over the adjacent side. So in our case, the opposite side is 4 square root of 3, and the adjacent side is 4. And then we need to simplify that, and 4 divided by 4 is just 1, so it just simplifies to the square root of 3. And then they want us to find that as a decimal, so we'll plug the square root of 3 into our calculator. If we round this to 4 decimal places, we get 1.732. 1. So 7.32, and then the 5 rounds this up to a 1. So 1.7321. Okay, now, since we're going to find the tangent of angle R now, I'm going to erase this because those are going to change. So now let's find the tangent of angle R. So we're looking at angle R. This didn't change. That's still the hypotenuse. But now 4 is the opposite side, and the remaining one, 4 square root of 3, is the adjacent side. So tangent of angle R, again, opposite over adjacent. So if we're looking at angle R, the opposite side now is 4, and the adjacent side is 4 square root of 3. And again, 4 divided by 4 is just 1. So we have a 1 in the numerator and a square root of 3 in the denominator. Now, you would technically have to rationalize the denominator here. I'm not going to make you guys do that, though. I'm going to take those out of your homework problems. So let's figure out what this is as a decimal. 0.5774. That 5 is going to round this up to a 4. So 0.5774 as a decimal. And that's how we find the tangent ratio. Okay, we're always taking the tangent of an angle. So find the tangent of 74 degrees. Well, we can just type that in our calculator. Here's the sine, cosine, and tangent buttons. So tangent of 74 degrees equals 3 point, oh, that's not right. Okay, my calculator is in the wrong mode. I'm going to go mode. We don't want radian mode, we want degree mode. So I'm going to enter. And now when I take so tangent of opposite over adjacent can't be negative because we're talking about side lengths, so that didn't make any sense. And it's because my calculator was in the wrong mode. There we go. So now 3.4874. So again, calculators have to be in degree mode. I'm going to skip these. These are just like the last example. Actually, I'll do them. Okay, so so first let's focus on angle S. So this is the hypotenuse. Always label that one first. Opposite is across from. So across from that angle is our opposite side, which means that this is the adjacent side. So the tangent of S is opposite over adjacent, which simplifies to 3/4 as a decimal. That's 0.75. Okay. Now let's look at angle R. So this is still the hypotenuse, but now this is our opposite side because it's across from, and this is the adjacent side. So the tangent of angle R is now, let's see, opposite is 8, adjacent is 6. And you'll be like, wait, Miss Kinsel, that's just flipped. Yes, it is. Okay, so the tangent of our two acute angles, R and S, are just flipped. So 4/3 is 1.3333. Repeating. So let's do the same thing here. Let's do tangent of S first. So this is hypotenuse. This is opposite because it's across from, and then the remaining side is the adjacent side. So tangent of angle S is opposite over adjacent, which can be simplified to 5/12. And if we do 5 divided by 12 in our calculator, we get 0.4167. And now let's do the tangent of angle R. So again, it is just going to be flipped. So now this stays as the hypotenuse, but if we're looking at angle R, this is now the opposite side. And then our remaining side is adjacent because this is right next to angle R. So now, again, it is just flipped. Our opposite side is 24 and our adjacent side is 10. So that's 12/5, which is And the last one, start with the angle you know. The tangent of 59 degrees equals, okay, this is my hypotenuse because it's across from the 90-degree angle. This is my opposite because it's across from the angle that I know, which means this is the adjacent. So tangent of 59 equals opposite over adjacent. So again, x is in the bottom, so we're going to multiply both sides by x. Since it's x times the tangent of 59, we're going to use our inverse operation and divide both sides by the tangent of 59, and we get x equals 5 divided by the tangent of 59 degrees, and that equals 3.0. So we can just say 3. And that is all for the tangent ratio.